Hi everybody, this is your video on distance formula. We're going to do some practice problems. So I'll do a couple for you, but then I would advise, just as you're learning, to try some of these on your own before you watch me do them. So like I'm going to do the first one, and then I'll give you a shot to maybe try the second one on your own. So I think I have 5 or 6 problems for you here with the distance formula. So let's just go ahead and jump right into it, okay? So the first couple here are just straight distance formula. Okay, so remember, keep in mind that the distance formula is d equals the square root of x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. All right, so all of our answers here are going to be numbers, either whole numbers, numbers with a simplified radical, or decimal values. All right, so let's go ahead and take a look at this. So step 1 is always label your points as point number 1 and point number 2. So I typically label the first point as 1 and the second point as 2. You can flip them if you want, it doesn't really matter. All right, so that means that -4 is x1, 2 is y1, 15 is x2, and 6 is y2. So let's plug those numbers into our distance formula here. Okay, so you have x2, which is 15, minus -4 is x1 squared. Extend my thing here, plus y2 is 6 minus y1 is 2 squared. All right. So again, and you've heard me talk about this in the notes video, but the only thing that you will change when you're doing the distance formula is these 4 numbers right here. This number, this number, this number, and this number. Everything else stays the same. Okay, so the square root, the minus signs inside the parentheses, the plus sign, the squares, all of those stay the same. All right. After you plug your values into the distance formula, you just have to follow PEMDAS. So I'm going to do what's inside my parentheses first. Okay. So, and what I have right here, I have 2 minus signs right next to each other. So those become plus signs. So I have 15 plus 4, which is 19. So again, I started with the minus sign in there, right? And then changed it to a plus sign afterwards, just so that I didn't confuse myself and drop a negative sign or put another negative sign in there by mistake. Okay, so I have 19 squared plus 6 minus 2 is 4 squared. Okay, so I did what's inside my parentheses. Now I need to do my exponents next. Okay, so I'm going to take 19 and 4 and square them both. Okay, so 19 squared is 361, plus and 4 squared is 16. All right, let me draw my little arrow here. All right, there's no multiplication, no division, so now we're at addition. So I'm going to add what's inside my parentheses. So 361 plus 16 is 377. Okay, and then my very last step here is I need to take the square root of 377. Whoops. I'm over here doing this on my calculator and I pressed the wrong button. LOL, whoops. Okay, so the square root of 377 is 19.4, and then I'm going to round up to 2, 19.42. All right, so that is my answer there. All right, so that's my answer. Okay, so in the next 2 problems here, I kind of want to give you a chance to try the next 2 problems on your own because they're both just straight distance formula. Okay, so the first one, they're saying they called it length of a segment, but they mean distance, right? Length and distance are essentially the same. Okay, and so it'll be the same process. All right, and then number 3 here, they only give you a drawing. right? They didn't give you coordinate points. So when they give you a drawing, you have to figure out what the coordinate points are first, right? So you need to get these 2 points, right? Whatever they are. Okay, so you got to use your knowledge of the coordinate plane to pick out what those points are. And it's having you estimate. All right, so I'm going to pause the video. If you want to pause as well and try on your own, do it here. You can also just keep playing the video if you want to see me talk these out. I'm not going to work them out fully live though. All right, so the next time you press play, you'll see the whole problem worked out on your screen. So I will see you guys in just a second. All right, everybody, so here are the next 2 problems worked out for you. So taking a look at number 2, this is very similar to number 1, where I just plugged the values in. So I labeled my first point y as x1, y1, and my second point z as x2, y2, and I plugged those numbers into the distance formula. I tried to color code them a little bit so it was easier for you to see what I was doing. So I ended up with 5 minus -2, which is 7, and -8 minus 6, which is -14. 7 squared is 49. -14 squared is positive 196. Remember, squaring something gets rid of a negative sign. Always, always, always. So be careful. So if your calculator gives you a negative number, it's probably because you keyed something in incorrectly, right? So when you square something, it's always positive. So then I need to add these 2 together, and I got 245. Now, there will be some questions that ask you to give your answer in simplest radical form, which is what's on the left here. So I kind of have 2 different answers here. They're equivalent. They're the same number, just expressed in different ways. So this one right here is if they ask you for simplest radical form. Okay, so this method that I'm talking about here, this one. So this right here, 7 root 5, is in simplest radical form. This, this square root symbol right here is called a radical. Basically what this is we're taking the big number, 245, and splitting it into 2 smaller numbers. And we're trying to get as much outside of the radical as possible so that the smallest number you can have, like that's possible with your original number, is left here inside the radical. Okay, so here's the way that you do that. Okay, you have 245 right here. I went through my list of perfect square numbers. So that's like 4, which is 2 squared, 9, which is 3 squared, 16, 25, etc., right? I went through my list of perfect square numbers, okay? And I found one that divided evenly into 245, and that number was 49. So you can split 245 into 2 factors, 49 and 5. 49 is the same as 7 squared, okay? So what I'm going to do is I'm going to take the 7 escapes jail, okay? That's always what my teachers would call it when we were doing radicals. They would say this, because it has a squared right here, it pays the time by giving up the squared, and so then it escapes jail. So 7 escapes jail, but the 5 is not a perfect square number. I can't write it as something squared, so it stays in jail. It stays inside the radical, okay? So this answer in simplest radical form is 7 root 5. So if a question asks you for an answer in simplest radical form, this is what they mean, okay? For me, I'm okay if you just plug this into a calculator. If the question doesn't say simplest radical form, you can just give me a decimal. So if you plug the square root of 245 into your calculator, you get 15.65, all right? Okay, so let's look at number 3 right here. So for number 3, they didn't tell us the coordinate points, okay? So the key thing that we want to remember here is that you can't just hop along a number line the way when it's diagonal like this in a coordinate plane. You can't just do this, right? Which is what you would normally do, like on a number line if you were counting, okay? That doesn't work. That doesn't fly. You can't do that. because it doesn't take into account the y distance that's happening, okay? So you have to get the two coordinate points, figure out what they are, and plug them into the distance formula. So that's exactly what I did. Okay, so point G up here is the point 2, 2, right? 2 over, 2 up, okay? And then the point F is -3, -4. So 3 to the left, 1, 2, 3 to the left, and 4 down, 1, 2, 3, 4. Okay, so now I'm going to take my values and plug them into the distance formula. So you can follow the work that I did here. So I have -3 minus 2, which is -5. -4 minus 2 is -6. -5 squared is +25. -6 squared is +36. I added those two together and got 61, and then I had to take the square root of 61 at the end and got 7.81. When you're rounding, for me, typically you want to round to 2 decimal places. That's usually fine. 2 decimal places is fine. All right, so we've got 2 more practice problems here for distance formula. So this is another way that distance formula problems might show up, where they give you the coordinate points of a shape. So here I gave you the coordinate points of a triangle, LMN, and I want to know the length of each side. So what I have to do is I have to use the distance formula 3 times so that you can get the length of each of the 3 sides. So I'm going to do the distance formula once with points L and M. Then I'm going to do the distance formula again with points M and N. And then lastly, I'm going to do the distance formula a 3rd time with points L and N. Okay. All right. So what I'm going to do is I'm going to work one of them out here, and then I'm going to pause the video to write the rest of them out. I suggest you do the same thing to see if you can get these on your own. All right. So for LM, I'm going to ignore point N, and I'm just going to use these 2 points, L and M. Okay. So distance is, I'm going to subtract my x's. So 7 minus 7 squared plus, and then I'm going to subtract my y's. So 4 minus 16. I know I'm going out of order. Technically, I chose L to be point number 2 and M to be point number 1, but remember, it doesn't matter which one you choose. So this one's just a little easier because I'm writing it in from left to right, okay? So one thing I want you to notice here is that you have 7 minus 7. So you're going to end up with 0 right here, okay? Whenever that will happen whenever you have like 2 x coordinates that are the same or 2 y coordinates that are the same. Because what this actually looks like, if you drew it on the coordinate plane, for example, you would have, say, this is the point L at 7, 4, right? Say this is 7, right? And then you had the point M, say up here, and that's like right here, this is 16, and this is 4, right? So see how it's a straight line up and down? Okay. All right, so you're going to end up with a 0 here, which means I can just get rid of it, right? I can just cancel it out, okay? All right, but let's write the rest of it out. So I have 4 minus 16 is -12 squared, okay? So now, looking at this, really what we're doing is this. Distance is the square root of -12 squared, okay? Now, essentially what's going to happen is you have this squared right here and this square root, and they're going to cancel each other out because they're opposites, right? So you don't really even have to do any squaring here, like squaring and then taking the square root, because you're just going to end up going like getting a larger number and then getting the same smaller number that you started with. But notice that this is negative inside here. So the reason we have the squared and the square root is to get rid of that negative sign. So when you put your answer in, you just have to make sure that you get rid of the negative sign. So the distance for LM is 12. All right. So I'm going to pause the video, and I suggest you do the same. See if you can figure out this answer is 12 right here. See if you can figure out the distance between M and N, which is going to be more like the problems that we've done previously because all the numbers are different, and then LN also. See if you can figure out what the distance is for LN, which is going to be similar to how I did LM because you have two coordinate points that have your y values are the same there. All right, so I will see you back here in a second. See if you can figure out the lengths of those sides, and then see if you can figure out part B, which is what is the perimeter of the triangle. Keeping in mind that perimeter is the sum of all the sides. All right, so I'll see you back here in just a second. All right, folks, so here's the other two sides worked out. So for MN, you should have gotten 37 as the side length. So again, I just plugged the numbers into the distance formula and got 37. You can kind of follow my thought process there. It's exactly the same as LM, exactly the same as all of the other problems that you've done. I'm hoping that you can see after doing multiple distance formula problems that they start to look really, really similar to each other. So if you can kind of get the process down of how to do them, then you should be okay when doing these types of problems, okay? And then for LN, I ended up with another 0 in there. See that I was able to cancel out. So I ended up with D equals 35 for that. So your side lengths are 12, 37, and 35. And then part B asked, what's the perimeter of the triangle LMN? So I just added all three of those side lengths. 12 plus 37 plus 35 is 84. All right, so give me just a second to clear my screen. I have one more problem for you. This one's definitely a challenge problem where we're going to have to do some solving. So I'll see you back here in just a second. All right, everybody, so here is our last distance formula problem. This one is a little bit different because you'll notice that you have a variable inside one of the points that they gave you. So we're going to have to work backwards a little bit here. Okay, so I have point R has coordinates 1, 3, and point S has coordinates 6, y. Okay, so and then they tell us that the distance from R to S is 13 units. So I know what D is. So in all of these other problems that we've done, we haven't known what D was, and that's what we were always trying to find. But here, I know what D is, and I'm missing one of these coordinate points, okay? So here, the question is, what are the possible values of Y? And I'm going to tell you that there are two possible values of Y, okay? And I'm going to show you what I mean, okay? So if we draw a coordinate grid, okay, so here's 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so here's my point R, and I want the distance to be 13 units. Okay, so I'm going to go, that point S is at 6 something. So it could be like way up here. S, right? That's a possibility, where this distance then between those 2 points would be 13, but you could also do that. This, if you think of this almost like a pendulum, this could swing down this way, right? And so I could also have S could be like down here, for example, where my drawing's not very good, but where this distance would also be 13. So we're going to have two possible values of y here. One that's probably positive and then one that's probably negative. So let's see if we can figure that out. Okay, so my distance formula is still D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now rather than plugging in every possible value for the x's and y's, because one of them is missing, I also have a number for D. Okay, so what I have here is 13, because that's D, equals the square root of, and I know what x1 and y1 are. So I'm going to call this point number 1 and this point number 2. Okay, so I have x2 is 6 minus x1 is 1 squared, okay, plus x2, or y2, sorry, is y minus, and then you have 3 is y1, and I'm still squaring it. Okay, so now we're going to have to do some algebra here because our goal, right, remember our goal is always to get the variable by itself. And right now the variable is trapped by a bunch of other stuff. So we have to cancel that other stuff out, right? So when you're doing this, you kind of want to work from the outside in. So the thing that is the furthest away from the y is actually this big square root right here. So to cancel that out, we have to do the opposite of that, which is to square both sides. Okay, so that's what I'm going to do. I've squared both sides. So 13 squared is 169. So you have 169 equals 6 minus 1 squared plus y minus 3 squared. Okay, all right, so now I can deal with some of this other stuff. Like I can simplify 6 minus 1 squared, right? So I have 69 equals 6 minus 1 is 5, and 5 squared is 25. Right? 6 minus 1 is 5, so you have 5 squared, which is 25. Okay, plus, and then I still have my y minus 3 squared. Okay, so now the next thing in my way is this 25 right here. So I am going to subtract 25 from both sides. Minus 25, minus 25. Okay, let me do my arrow here. Okay, so now I have 144 equals y minus 3 squared. Okay, again, we're still working from the outside in. So the thing that's farthest away from my y at the moment that's in my way is this squared right here. So I need to cancel it out by taking the square root of both sides. Okay, so those cancel out, and I'm left with y minus 3 on the right-hand side. Now, this step is where we have two different paths that we can follow. Okay, this is going to split us into two different paths. Okay, here's why. When you apply a square root, okay, so not when it's in the formula originally, but when you apply a square root, you have to remember that there are two possible numbers that when you square them, you would get that squared number, right? So we know that 12 squared equals 144, but negative 12 squared also equals 144. So we're going to split. So we're going to have two equations here. So on the left, we have 12. Actually, let me change my, change my pen color back here. So on this side, I have 12 equals y minus 3. And on the right side, I have negative 12 equals y minus 3. Okay, so then my last step on both sides is I need to add 3 to both sides. Plus 3, plus 3. Okay, and I'm doing that for both. Okay, so that cancels out. So what I end up with on the left, 12 plus 3 is 15. So one of the possible coordinates for y is 15. Okay, and then negative 12 plus 3 is negative 9. So that is my other possible y value. Okay, so this coordinate, this one down here, would be 6, negative 9. And this coordinate up here would be 6, 15. And if you plug these two values, the 15 and the negative 9, if you plug them into the distance formula, or you plug them back in up here, you will get that the distance is 13. All right, so I know that one was a little bit tricky. This is about as tricky as distance formula problems get. All right, and typically I wouldn't ask you a question like this on a test. This is definitely more of a thinking type question or a challenge type question. All right, so in the next video you will see some midpoint notes and then some midpoint examples and practice problems. So I'll see you in the next video. Bye everybody.